Okie doke. Well, welcome everybody. Hopefully you're not sweltering in the lovely weather we're having. Okay, let me throw it open. I know. Yeah. So Bob, you said asking about ground loops. How did that come up?
I get it. I don't really like to move. The last install I did, the way I had it drawn, the electrical guys who did the installation, the boss says, well, that can cause a ground loop. It didn't sound right to me, but he had it wrong. But maybe we still did have a ground loop going there.
Okay, so did you have, first off, were you connected at two different ground rods?
There was an existing small system on the garage that had its own ground rod. And then there was a ground rod that Edison put in for their system.
Okay.
And I just took it right off of that because the spec calls for me to put a ground rod in and then take a special insulated type of wire and connect the two ground rods together.
Yeah.
And if we do that in Ohio, you got to put it in a conduit or BX or something.
Connecting
like
two ground rods together, it's got to be in conduit?
That's what you told me in class. See, I happen to have that memory that you did a system and then the guy had you tear it up. We talked about what to expect from inspectors.
Oh, okay. Well, let's see. If I said that, I think I was wrong. I did have, no, usually what you do is if you've got two ground rods, you're just going to connect them, again, typically with bare copper 6 gauge, hook them together, and that then evens the potential between those two ground rods, which then can avoid that ground loop. The question is, how far apart do these ground rods have to be before ground looping is no longer an issue? And that's one of those, you know, that old saying about pornography, you'll know it when you see it kind of thing. You know, the inspector kind of is like, I'll know it when I see it. It seems too close or it seems too far away. You know, if it's say, I don't know, 50 feet, I wouldn't imagine that's an issue. If it's 20 feet, maybe. You know, you're not supposed to put two ground rods closer than 6 feet together. But then you're supposed to connect them together. But how far apart? I don't know. I mean, has anyone come up with anything definitive on that? Or it's typically just the inspector kind of goes, why don't you hook those together? Anybody have a feedback on that? Nope. So we'll just take my assumption. I think that would avoid your ground loop, I hope, I think.
All right. So I saw one system had 3 ground rods in it, one from Edison and 2 they put in.
Yeah.
But then did your eyebrows go a little bit high when I said I used the Commonwealth Edison's ground rod?
No, not at all. I mean, that's fairly typical. You just are going to be hooking in, especially with a transformerless inverter. Used to be that you had to have a DC inverter or a DC ground. But with most of the inverters today, there is a connection between the DC side of the inverter and the AC side. So they allow you to just tap into the existing electrical ground, which will be the AC. And that's usually done, you know, straight through the inverter. It connects in the service panel, and in the service panel is connected to the ground. So where we used to have to install a secondary ground pretty much all the time, that's getting to be more and more rare. Although still some inspectors want you, let's say you're putting in a solar edge system, you can hook in a ground rod to the inverter, and then they want you to tap those together, you know, to the existing ground. So that's all doable. And depending on your soil type, I know somebody in Kentucky was telling me they require 2 ground rods for everything. Just because apparently they don't think that a single ground rod has enough connection to the soil based on soil type. You know, now when we do wind turbines, you actually do a grounding circle, you know, put in multiple ground rods all around the wind turbine and connect them together in a circle. So, you know, having 3, having 5, having 12 really doesn't matter. As long as they're all hooked together, it's basically one big ground rod.
Is that for lightning protection?
Yeah, primarily because it's basically a huge lightning rod standing out there. And they'll often even put in a wire mesh that covers the entire site, you know, and it's all hooked in. With the big ones, of course, they've got a great rebar reinforced base. Or you can get an oofer ground, like in a commercial building, you just tie into the foundational rebar of the slab, you know, and that becomes your ground. So it's really just getting you a good connection to earth.
Bob, do you actually have a ground loop, or was this supposed?
Bobby's asking if you had one. I think you said that the electrician just said it would cause one, right?
Well, my original plans was to have 2 of them. And it did have the number 6 between the 2 on there. But it had to do with something completely different. And the way he talked, it didn't ring true to what I remember we talked about in the past. So that's why I brought it up.
If they're connected together, I don't see how you possibly could have a ground loop.
Yeah.
I mean, you basically have one ground. So I don't know exactly what the consequences of having a ground loop is. I know with audio, you get bad distortion to the signal. So I suspect it's similar to that.
Well, anything with a computer in it, it better be grounded and grounded good, because even the slightest differential on that will take out integrated circuits.
Yeah. And pretty much everything's integrated circuits anymore.
No, you can't get them anymore, Jay.
Oh yeah, yeah. I got a direct tie into China, so I'll get them. No problem. All right. Anybody else have a technical issue here that we can touch on before I jump into what I was going to talk about?
Jay, not a technical issue, but a little bit deeper discussion on your ground loop issue. This is Dan.
Okay.
Particularly related to things like ground fault circuit interrupters and so forth, you can have both a DC or an AC side ground fault. But more commonly, the ground fault detectors are built in for the photovoltaic side. And if you actually do have a ground loop, and depending on where the inverter sits in relationship to that potential within the ground loop and this potential difference, it actually can create a false ground loop and trigger the system, or actually mask an existing one, depending on which direction. If there's a DC current flow from the AC side, you can have the same thing where it ultimately shifts what we call the baseline, which should be 0, up or down accordingly.
Am I right in assuming that if you've got just simply one ground, whether it's 2 poles connected together or just simply one, that a ground loop is not realistic, just can't happen?
You're correct. If you bring everything back to a common ground, then it's not possible to have a ground loop. Conversely, you can have multiple ground rods, which there was a little bit of fence sitting on both sides of that argument, provided the ground rods themselves are bonded together, and it's done to lower the impedance between the ground rod and earth, or the ground system rather.
Yep. I wonder, often with the ground mounted systems, they want you to have a ground rod at the array. And then another ground rod, of course, will be within your existing system your electrical system now, usually, typically. But those might be 100 feet apart. Do you see any potential of a ground loop in a situation like that?
Only where the DC side ground fault circuit detection is concerned. And yeah, it can cause problems. And I understand that you had postulated 50 feet as kind of an arbitrary distance inside which multiple grounds would probably not be a bad idea. And you were actually quite very much on target. We have multiple purposes for each of the ground conductors in these systems. One, as you've already touched on, is for lightning protection. Wire has inductance per unit of length. For every foot of wire, you have so many nanohenries, for example. Lightning is comprised of various elements ranging from effectively a very high stroke DC up to hundreds of megacycles into the gigacycle range of RF. Consequently, the longer the ground conductor in this case, the less effective it becomes as a DC or as a conductor for that lightning. Conversely, again, if you have a ground at the array and then a ground back, say more than 50 feet away, that's been deemed generally acceptable, and that's actually got its basis in radio frequency grounding for transmission systems. Anytime we've had something farther than about 50 feet, the conductor from a lightning perspective conducted to Earth becomes less and less effective. Second purpose of the ground is to actually act as a drain. Lightning originates when you have leaders that stream upward from a lightning rod or other metallic object. And the ideal thing would be to have the ground rod and ground system discharge that static before it builds to a point where it becomes attractive as for the existing lightning. Same way that when you walk across the carpet in your shoes and touch something metal, you get a spark. If you take your shoes off and walk across just in your socks, just enough moisture between your feet and the carpet and everything else allows that to drain out just as fast as it builds up. Objective here is to prevent the static buildup from occurring in the first place. And it does so by keeping everything essentially at the same potential as the Earth around it. Your 50 feet was a reasonably good figure, as a matter of fact, based on RF. And if you do have multiple grounds, you can certainly do them within 6 feet of each other. You bond them all together and you're effectively paralleling resistances to Earth and decreasing that total impedance and resistance from the ground rods to Earth. So I'm sorry for the long explanation, but yes, you are correct.
Okay. All right. Well, better to be lucky than good, I guess. I'll just make stuff up, and half the time I'm right. Yeah, Bob, do you have?
A sub note to that is there's a lot of electricians who actually believe to take the green ground and hook it up to the neutral in your boxes. And what happens next is not pretty.
Yeah. Well, I think that must come from the fact that typically in the main service panel, your neutral is grounded, and it doesn't really matter. You can hook your grounds in with the neutrals in that box, but not in a sub panel. But it's not recommended, I think, for most of our stuff.
If you go out to your Edison ground rod and put an amp probe on it, and it's hooked up to the white wires, you're going to be very amazed on how much amperage is going right to the ground.
Okay. Yeah. Well, that sounds like it's something that I think you'll find electricians, like any other field, good ones and bad ones. So I wanted to touch on PID. And the reason I mentioned this is because it was something I came across, and I'd run across it several times before. Didn't really understand it that much, but it's something that you'll run into, and it could have a big effect. PID is potential induced degradation. And where this comes in is with high voltage systems. So right off the bat, microinverters apparently are not subject to this because the voltage is not great enough at 240. But what they find is you can experience almost immediate or long-term, it sounds it's all over the place, up to say 70% loss of your power from your string. And it may be one of those things that's really tough to diagnose. So I want to make people aware of that. I had a guy who had come out to Blue Rock Station and was talking about his array and had something like this happen, where he had it installed and then just saw a fairly rapid and significant fall off in production, and he was trying to figure out why. It is essentially, there's I guess a stray current discharge between the PN junction of the panel and other component pieces within the panel. So the glass, the frame, the anti-reflective coating, all of these things can essentially generate a discharge, which then bleeds off, and it actually changes the shape of the IV curve. So where the IV curve is normally going to go like that and then cut down, it'll sort of make it more of an angle. And it is correctable. So that's one reason that I wanted to bring it up. They talk about prevention of it, and it sounds like keeping your system voltage low is one item, but that doesn't sound like a good thing because that increases voltage drop and wire size and all this other stuff. So we're always pushing more towards higher voltage. The quality of the panels. So if you get good quality panels, that's a thing. And of course, the higher the heat, the higher the humidity, the bigger the problem. But they sell these little PID, anti-PID devices that you simply hook into the string, between the string and the inverter. And I looked online to see how much they were. The only one I could find marketed out there in the general public was running about 180 bucks. And it simply hooks into the string. And apparently what it does is it monitors the voltage levels of that string during the day, and then at night disconnects from the inverter and then sends a complementary voltage signal back to the panels. And apparently this fixes whatever it is that's going on in the panels. They say that within a week or so, your panels and everything will be operating just dandy. So something to be aware of if you run into that as an issue when you're out there diagnosing, where perhaps you have one string that's suddenly underperforming, can't figure out why. It may be a PID issue. So it can be corrected just by installing one of these correction devices. So does anyone else have any comment or greater understanding of what potential induced degradation is, or the PID? Has anyone run into this? Nope. Okay. I was looking through all of the news, and about the only thing that I saw here was that the Solar Edge has come out with some larger systems for commercial installation. They've got a 120 kW, a 100 kW, and an 80 kW inverter system. And those are at 480 volts, 3-phase. And then they also have a 50 kW inverter for 208 volt, 3-phase. So if you're running into some of these larger systems, I mean, 120 kilowatts is a pretty big system. So Solar Edge is moving heavily into that. And they do say that they've got 150% DC oversizing, you know, the clipping ratio, load to inverter ratio. So with a 100 kW inverter, you could actually have a 150 kW DC source. So that's a big system. Then I think the last thing I was going to touch on is Eric had shared a system design. So Eric has graciously agreed to be ridiculed and embarrassed in front of the group by taking a look at his system here. So this is, Eric, why don't you walk through and tell us a little bit about what you're doing here, and then we'll see what we've got.
All right, well, the property with the field was where I grew up, and it is now a rental, but since I pay the electric bill and pay the other bills, it's still considered part of my household, so I can net meter that property and the property to the south there, which is where I live. They're within 2 miles, Unilex says I can do that. So in the pasture there east of the house, I want to put up about a 12 kW array. And I want to take that down and bring it in. And my concerns are, one, voltage drop over 400 feet. Another, the size of the array might exceed the bus bar rating on the service panel that's in that existing house, which I'm thinking of a 200 amp, but I looked at the fuse after I did this and it looks like a 100 amp.
Oh,
so
well, if it's 100 amp, I can tell you right now, you've exceeded it. Yeah, if it's a 100 amp service panel, I should say, you know, if you've got 100 amp service coming into a 200 amp panel, you're probably going to be okay. So the couple of things I had a question. You said that your utility says no problem, meter them both, or at least allocate the production to both
Yes.
of your bills. So so you're really just talking about oversizing a system and connecting it to this one house, right?
Yes.
Okay. So if I come down here, you're saying that you want to have, you had decided 28 430 watt cube cell panels, and then you're going to hook those up to the IQ7s. The IQ7s are 295 watts, right? Output?
I believe so, yes.
Yeah, so basically what we're talking about then, my calculator's not gonna work, but
Yeah.
rather than 28 times 430, when you're talking about your output of your array, it's gonna be 28 times 295 for your AC output. So whatever that happens to be, if somebody's got a quick calculator, they can tell me, but I'm gonna guess it's gonna be 8,000 and something.
It's 8,000 and something, and then if you multiply it by
times 1.25. Yeah. So it may be, so what we would have to decide is, all right, well, let me go ahead and I'll stop sharing that, and then I'll get my little whiteboard here. All right, so we'll see if I can get this to work. Oh, okay, so if you've got your solar array here, and you're going to do N phase, you've got 28 panels, and let's assume that you're going to come off of here and go to your N phase combiner box right out there at the array, rather than running 2 strings or whatever, or you were running into some issues with the communication device as well.
Yeah, we discussed that last time. I was looking at 3 strings because according to the microinverter, you're not supposed to have more than 11 of the IQ7 Plus hooked together.
Okay, all right.
But I didn't want to combine them and run one wire to the house. But again, my voltage drop question and the gauge was.
Yeah. Okay, so if we do this and let's say they're 295 watts and it's going to be 240 volts. So that's going to be about a 1 point, I don't know, does anybody have a calculator for amps? Oh, here, my calculator's sort of working. I should be able to do this in my head. 1.23, 1.23 amps, right, for each one. And you said that we're going to be hooking up 11 in each one? Max?
Well, if it, yeah, 28, 10, 10, and 8, or whatever that works out to be.
Yeah. All right, so let's say the maximum is going to be 10. So really we could, however we're combining them, we're really going 28 times 1.23. So times 28 gives me 34.41. And then we want to multiply that times 1.25. So 43 amps. All right, so this wire here has to be rated for 43 amps, right? Just for the current. All of this here is really going to be typically 12 gauge, right? Because that's what the end phase cable comes in at.
Right.
So that handles, that's why they limit you to 11, because it's only rated for whatever, 20 amps. So 11 times that, times 1.23 times the 1.25 gets you in at that. All right, so if we look at 43 amps, we'd look at the table if we're just worrying about current, and we would say, I don't know, I'd have to look on the table, but my guess is 6 gauge, something like that. Isn't that 55 amps?
Yeah, my
rated?
question there, Jay, is if L1 is carrying 110 and L2 is carrying 110, does one single cable carry 240?
Yeah. Does it really matter? We're worrying about the amps, not the voltage.
Okay.
I think they'd both be carrying the 1.23 amps. So that's the issue for cable sizing.
Okay.
Jacket, whether it's rated for 300 volts or 600 volts or whatever, that might be an issue, but it's not going to be. So 43 amps, but then you also wanted to worry about voltage drop. And of course, voltage drop is going to be amps times resistance times twice the distance divided by 1,000 feet, right, for calculating voltage drop. So if we say that the voltage drop is 34.41, and depending on the cable that we've selected, does anyone, we'd have to look up the table for the resistance characteristics of, let's say, 6 gauge cable. Does anybody know that offhand?
I looked up the info for the 10 gauge. It was 1.21.
Yeah.
That's not going to help with the 6 gauge.
Yeah, we could, let me see, I'll jump over here to a screen. See if it pops up real early. Resistance per 1,000 feet for 6 gauge looks like 0.3951. 0.3951. Okay, so I gotta find my. All right, so if the resistance is going to be times 0.3951, and you said the distance is how far? 400 feet?
400 feet.
Yeah, so 800 feet divided by 1,000 is going to be 0.8. So if I do the 34.41 times 0.3951 times 0.8 gives us a voltage drop of 10.87, or let's just say 11 volts. And 11 volts over 240 gives me about a 4.5% loss, which is pretty high.
Yeah.
So you might want to go with, let's see, 4-gauge cable was 0.2485. So if we just take that and instead do a 0.2485, then it's 34.41 times 0.2485 times 0.8, 8.5 divided by 240 gives us 3.5% with 4-gauge. Okay. Well, one of the issues you've got there, and I mentioned this because I was just down buying wire, and I felt like I had to take out a mortgage on my house to get that wire. That's going to be a lot of money to get the bigger wire. I don't quite know what your alternatives. 400 feet is going to be a lot of money regardless. You've got an option of running like 10-gauge wire all the way, three circuits of it. I guess the question I would have is are 3 strings of 10-gauge wire going to be cheaper than 1 string of like 4-gauge wire?
When I priced it, the answer is yes.
Yeah.
So
Okay.
I was considering just putting bigger conduit, but
Yeah. I think you'd probably be better off that way. Then your box is going to be sitting there at the house rather than out at the array, which might give you the communications access. You could tap into your Wi-Fi if you
well, I
have.
don't have Wi-Fi there, but yeah, that's potentially available.
Yeah. But, 400 feet, does it have to be that far out? I mean, it looked like on your picture, you could put it closer.
There's some substantial trees in the shading.
Oh, okay.
I didn't know how close I could do that and still, the angle of the sun at that point would be fairly low, but it's still quite a bit of sunlight. So,
Well, if you need to borrow the solar pathfinder, just let me know. I can ship it up to you, and you can see if shading's going to be an issue. Find a location. But if you do move this closer to the house, you're going to want to put some sort of disconnecting device here at the array. So
well, the plan was for both locations. Put a disconnect at the array and a disconnect at the house.
Yeah. Except if you're running 3 strings, you're going to have a disconnect that allow you to turn off all 3 circuits.
Yeah.
So, and then at the house, you're going to have an AC disconnect anyway.
Right.
There. Now the question is, can you do a load side or a supply side connection? And it looks like it's going to be coming in at 34.41, but with the 1.25, you're at 43 amps. And if you had a 200 watt panel, say, with 200 watts or 200 amp service coming in, let's say the panel itself is 200 amps, then because of the 120 rule, you could do a load side connection and go up to 40 amps, because you've got 200 amps coming from the service, from the utility, 40 amps coming from the array, and you're allowed to go to 120% of the bus bar rating. So if you have this service panel that's rated at 200 amps, and you'll just have to look at your service panel, to
Right.
see what it is rated at. You said you looked at the main and you thought it might be a 100 amp?
Yeah, I had the house rewired before I turned it into a rental, and the guy did replace the service. And I thought it was a 200 amp service that went in. But I would have to go double check on that.
Okay.
And so-
Often they have service panels that are not just 200 amps. You might have a 225 amp service panel. If that's the case, not a problem. You're all set because you're not going to exceed 120% of the bus bar rating. And also, if you've got only 100 amp service coming in from the utility, but it's a 200 amp rated panel, in theory, you could go 140 amps coming from your array and still be okay. So that's kind of going to have to be, you're really going to have to see what is the service coming in from the utility. You can see that just on the main breaker. And then what is the rating of the service panel,
Right.
which should be in that label that's right there on the inside of the panel.
Okay.
And you're not allowed to exceed, in combination with all power sources, more than 120% of the service panel rating.
Right.
So one alternative is, let's say it's 220 or it's 200 amp panel, 200 amp service. You could have somebody, you'll have to disconnect from the utility, but put a 150 breaker in there, for instance, from the utility, and then you're fine. Unless the guy's doing welding in the middle of the night, it's probably not going to be an issue. So.
No.
All right.
So if I brought those 3 legs down, those would go onto separate breakers anyway, wouldn't they?
Yeah, they're going to go on separate breakers in the combiner box from Enphase. So this Enphase box has 4 different ports for breakers.
Okay.
So you're going to land each of those strings. They're not strings, they're branch circuits. You're going to land those in those breakers, and then leave with just one larger wire. So it's a combiner box. Whether you do that here at your house or you do it here at your array, it's going to happen. So, and that's also kind of, that combiner box is a good place to put your surge protection if it's going to be out there at the array. If it's not, I would put your surge protection on the disconnect switch, and hook into that somehow, just to provide for lightning protection out here.
Right.
And of course, as we just discussed earlier, you're going to have a ground rod out there,
Right.
and connect that in to your grounding system, because in that disconnect or in this combiner, there's a ground bus bar, and you just connect your ground rod there. So.
All right. Another question I had too with the IQ7s is you have the 2 hot leads, but you don't have a neutral now.
Yeah.
Is that going to be an issue bringing it down to the house? Is someone going to question that?
No, but it freaks me out. I don't know why they don't put the neutral in there, but apparently it's just simply not required. So I don't know. You're right. It has 2 hots and it doesn't have a ground either, so no equipment. It's grounded through the casing of the unit. But no, I mean, I've had electrical inspectors look at it. They seem to be quite comfortable with the fact there's no neutral.
Okay.
All right. Anybody have any questions on this particular item? Okay, so hopefully, Eric, if you could look at your panel, let me know on that. But, we can take a look and see if there's any issue, but it seems pretty straightforward. Yeah, Bob?
Correct me if I'm wrong, but I thought the Enphase combiner boxes has 3 inputs from 3 strings and a 4th one for the battery.
Yeah, I think it can be used for that, but I think you could put 4 strings in as well. I'm pretty sure, they just say it has an 80 amp capacity, you know, and there are four breakers. I think typically most people do 3 strings and a battery backup, you know, in there. But I think you could put 4 strings, or not, we keep saying strings, but they're branch circuits because they're not connected in series. Yep. And it has the communication system in there as well. So, all right. Any other questions for the good of the cause? Yeah, Bill, you're on mute.
Yeah, I had a question. Panels, they say degrade at 0.5% per year. And I was wondering whether that's the current or the voltage or what, whether anybody knows about that. I just scored 30 panels were donated to a charity, and they've been up eight or 10 years. So I'm wondering, yeah, voltage or amps degrades over time.
Yeah, I'm not sure. I mean, I can give you my feedback and maybe somebody else has something, but my understanding is the 0.5% per year has been for warranty work. You know, basically the warranty says we'll accept 0.5% per year so that at the end of the 25 years, if it's operating at 87.5%, we consider it to be fine. But that tests in the field have shown it will degrade quickly at the beginning and less so as it ages beyond that. You know, so it might have maybe, let's say in the first 2 years, it might lose 1%, but then it'll level off because a lot of that loss is in, you know, marring of the anti-reflective or, you know, yellowing or dust or who knows what it is. I mean, dust is temporary, but I did read an article where they said 0.5% is generous as far as degrading. But I haven't seen anything that talks whether it's voltage or amps. My assumption would be amps because voltage is more temperature related. Amps is irradiance related. And I would assume it's the amps that are being affected primarily. But that's just my guess. Bob, you have?
To me, whatever's going out from the panel, when it hits the microinverters, it's going to go up to 240, whatever it is. Yeah. And at that point, the thing that's going to vary is going to be the amps. And basically, it's what the manufacturers are looking at, the amps. And my numbers show that 1 to 1.5% the first year degradation, and then it slowly goes from there.
So does it drop off almost to 0 unless there's something physical that happens? I mean, it doesn't get better, but the amount of decline.
Right. It depends upon the panel manufacturers and the type. But I've seen it anywhere from 1 to 1.5% the first year.
Yeah, that makes sense.
And then it goes down from there. And the panels I've been putting in guarantee to be at 89% after 35 years.
Oh, okay. All right.
But that's an exceptional panel.
Yeah, I think your point that because most panels now have some electronic device attached to them that regulates the voltage, whether it's a microinverter or a power optimizer or whatever, I guess the resulting effect is going to be a decline in amps, regardless of how it started out at the panel. That's what's going to be generated from your array, because the voltage is going to be set with microinverters to whatever the utility is, and a power optimizer, it's going to be about what, 400 volts, something like that, you know, because it's a fixed voltage. Does that answer what you're looking for, Bill? Yeah.
Yeah, it seems reasonable. I mean, I think voltage is a function of the physics, and that doesn't change. And so it seems logical that it would be amps.
Okay. Now, I was going to ask you, because with that PID issue, the only way of really diagnosing it is to hook up and test the IV curve. And you were showing, you've got all the gadgets and stuff. Apparently, there's a device you can hook up to a panel that will generate an IV curve for you. Is that something you've
No.
worked with?
No, I have not worked with it. I've toyed with the idea of hooking a variable resistor to a panel and sweeping the IV curve that way by the amount of amps that comes out of it, and doing a plot, but I have not done that. So I can't, really don't have anything to add in that regard.
Okay, I think they make a tool that does that. You just hook it
Yeah.
up and it generates it. But that's something I don't think most installers have in their toolkit. So,
Right.
okay. Anybody else have anything for the good of the cause? Nope. Okay. All right. Well, we'll see you all next week. If you have any questions in the
All right.
meantime, send them my way. We'll try and get them answered. All right.
All right.
Okay. Take care. Enjoy the heat.
Thanks, Jay.
Thank you.
All right. Bye-bye.